Hello, today I'm going to show you guys how to solve inequalities, both 1 and 2 steps. So please take a moment to write the title and actually everything on this page for me. Some key points I want to point out to you is inequalities, we can graph them. So not only are we going to solve them and write them, we're also going to take the time to graph the inequalities. And they represent a set of points that are solutions to the inequality. So we're going to make an open circle, so in other words, like this one that's not filled in, if we have a less than or greater than sign, and then we're going to have a closed circle, also, spoken as filled in, if we have less than or equal to or greater than or equal to. So go ahead and pause the video and write those items down. All right, one-step equations. Let's first look at writing a few inequalities if we are given a graph. Example 1 on A, let's go ahead and look at the dot. It's a filled-in dot, so that means that we're going to have an equal sign underneath our inequality. The inequality is pointing to the left. If it's pointing to the left, that means that it's going to be a less than as well. All right, so let's go ahead and just choose a variable. Let's choose x. And then, again, I said it's filled in, and it's less than. So we're going to do less than or equal to. And then we just write the number that the dot is on. All right, on B, again, we're going to have an open circle. So we're going to start off by writing x, and it's going to the right. If it's going to the right, that means that it's greater than. And again, we're not going to write equal to because it is an open circle. And then, of course, negative 6.5. All right, moving on to example 2. It says solve the inequality and then graph your solution. Here we have a one-step inequality. So think of these just like you would if they were equations. One-step equations means that we're going to try to get the variable by itself by completing inverse operations. So we're going to look at this minus 9, and we're actually going to add 9 to each side. When I do that, I end up with x is less than or equal to 12. And then again, I want you to graph your solution. So we've got a 12, so maybe we start off with 0, and let's go negative 4 over here on this side, and 4, 8, and 12, and it's less than or equal to 12. So we're going to, sorry about that noise, we're going to make it a closed-in dot because it's also equal to. And then it says less than, so that tells me I'm going to go to the left. So less than always goes to the left, and greater than always goes to the right. Okay, looking at example 2b. Again, we're going to try to get the m by itself, so we have to add 1/2 to both sides. When I add 1/2 to both sides, I'm left with m on the right-hand side, greater than or equal to, and then negative 1 plus 1/2 gives you negative 1/2. And then the really important thing that I want you to point out, want you to notice here is that m is on the right-hand side. We don't want to keep it like that. We always want to go ahead and switch the sides of our variable and our number to always have the variable on the left-hand side. But when we do that, we can't just leave it the same inequality. We have to actually reverse the inequality. So now we have to make it a less than or equal to symbol. Okay? So please write down this important note over here in purple. Don't forget to always get the variable on the left side. All right, let's go back over here to graphing. Maybe I just start off with 0 in the middle, and a 1, negative 1 over here, and a 2. We'll go negative 2 over here as well. All right, so, oops, sorry about that again. I keep changing colors, and it makes that sound. All right, so m is less than or equal to negative 1/2. So that would be about right here in the center, and again, I'm going to fill it in because it's also equal to it. And then it says less than, so I'm going to go to the left. So less than is left, and greater than is to the right. All right, let's move into something a little bit harder. These are multiplying and dividing. Again, we are trying to get the x by itself. So this is x divided by 3. So the inverse operation of dividing by 3 would be multiplying by 3. So I'm going to multiply everything by 3, each side by 3. When I do that, these end up canceling each other out. So I'm left with x is greater than 24. Example 4. Multiply by a negative 6. Multiply by a negative 6. when I do that, guys, the important thing that you got to note here is when you are multiplying or dividing by a negative number, you have to be sure to reverse the inequality symbol as well, okay? So since I multiplied by a negative 6, I should end up with, let's see, negative 42 on this side. And since it was less than, I have to reverse it to be greater than. Example 5. Again, I'm multiplying by a negative 3 to both sides. So again, these cancel out. I'm left with x is greater than a positive 6. And look at there, I messed that up. What do I have to do with the greater than sign? I have to switch it because I multiplied by a negative 3. So this would actually be a less than negative 6. All right, on example 6, we need to divide by negative 3. So just like multiplying by a negative, when you divide by a negative, you also have to switch the sign. So sometimes students will go ahead and just switch the sign at the beginning so that they don't have to worry about doing it after the math. It's up to you which way you want to do it. So again, we have x is less than, and then 24 divided by negative 3 would give us a negative 8. And then example 7. Notice here in example 7, I'm dividing by a positive 5. So even though my answer over here is going to be negative 9, since I didn't divide by a negative, my sign stays the same. So again, make sure you have written down this note up here. And remember, it's only when you're multiplying or dividing by a negative number, not when you end up with a negative answer like example 7. All right, let's move on to two-step inequalities. So again, guys, you should be pretty good at these. They're very, very similar to equations. Just have to do a little bit more. The other ones we decided to not graph, but these problems we are going to graph. All right, so looking at example 8a, 10b minus 8 is greater than negative 68. So again, I'm going to start by adding 8 to each side. So I'm left with 10b is greater than negative 60. I then have to divide by 10, divide by 10. So my answer is b is greater than negative 6. And again, I didn't have to switch a sign because I divided by a positive 10. All right, I'm going to have an open circle because it's just greater than and there's no equal sign underneath. So I'm going to go down to negative 6, draw myself an open circle, and then since it's greater than, I have to go to the right. So that means that all of these solutions to the right would work if I plugged them in for b. So let's take a look. What if I plugged in 0? Is 0 greater than negative 6? Why, yes, it is. So I'm correct with my graph. All right, let's go on to example 8b. Again, I'm going to start by subtracting 6 to each side. So I'm left with negative 6n is greater than negative 54. I'm dividing by a negative 6. So again, just like on the previous slide, I told you that when you divide by a negative, you must switch the sign. So this would actually be n is less than a positive 9. All right, so I'm going to go down here, again, make an open circle at 9 since there's no equal sign. And since it's saying that it's less than, I'm going to go to the left. So make sure that you are copying all of these examples down, especially their graphs too. All right, let's go on to example C. All right, so again, I'm trying to get n by itself. So we always want to take care of the 1 first, the lonely one without the variable. So we're going to subtract 1 from this side and subtract 1 from the left side. So I'm left with 5 is less than n over 2. And again, to get the n by itself, instead of dividing by 2, I need to go ahead and multiply by 2. So let's multiply each side by 2. So 5 times 2 is 10. I'm left with 10 is less than n. And if you remember from the very first slide, I told you that you got to be careful not to have the variable on the right-hand side. So we have to switch it and make it n on the left and 10 on the right. And when we do that, we have to also reverse the inequality. So it has to be greater than. So n is greater than 10. Again, I'm going to draw an open circle on 10. I didn't make any of these equal to. Sorry about that. All right, so then, again, it's a greater than symbol, so I'm going to go to the right. And I'm done. All right, you are going to see a few examples like letter D here as well, so don't forget to pay attention to this one. Remember that when you have a big fraction bar like this, you just have to get rid of that bottom denominator first. So instead of dividing by 2, we're going to actually multiply by 2. So you always multiply by the number that is on the bottom here. And then we're going to multiply this side by 2 as well. So 2 times 2 is 4, which is less than or equal to. And then again, these end up canceling each other out. So you're just left with what's on top of the numerator. All right, and then we're going to add 3 to get the a by itself. So I'm left with 7 is less than a. And again, I've got my variable on the right-hand side, so I need to switch it. So a is on the left, and the 7's on the right. And again, it was less than, so now I need to make it greater than. I'm going to go down here, open circle on 7, because there's no equal sign, and I'm going to go to the right, since it's greater than. All right, here is your exit slip. Please make sure that you do these as well.